Hi guys, so we're looking at 3.2 today, half interested. So let's go ahead and get started. So for this first part, we're looking at simplifying each of the radicals. Whoops, where is this going? Sorry, I don't know what the computer just did. Anyways, we are looking at simplifying the radicals. So it has a couple examples for you. So we have the square root of 20. We can split that into the square root of 4 times, or the square root of 4 times 5. We can take the square root of 4. It's 2, so that's how we get the 2 on the outside and the 5 left underneath. The other example, we have the fifth root of 96. So 96 is 3 times 2 to the fifth power. So because it's the fifth root and it's to the fifth power, the 2 comes outside, and then we're left with the fifth root of 3. So 2 times the fifth root of 3. Sorry, can't talk. So we're going to look at a few of these and go through a few different kinds of ways to take and answer them. So we have the square root of 40. Now, how I like to think about it is, what is a perfect square that goes into 40, since we're dealing with the square root? So I have a list of all our perfect squares. So we've got 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121. So that's the first 11 perfect squares. So if we look at those, which one of those could go into 40 evenly, meaning divide into 40 and get another whole number? Well, 4 can. So square root of 40 is the same thing as square root of 4 times 10. Now, we can take the square root of 4. Square root of 4 is 2, and we're left with 10. So our answer, the square root of 40, is the same thing as 2 root 10. So this is the simplified version. Now, number 3, we're looking at the third root. Once again, I wrote out the roots. So this will be helpful for you guys as you're doing these. So here's the perfect cubes. So 1, 8, 27, 64, 125, 216, 343, 512, 729, and 1000. So that's the first 10 perfect cubes. So we're looking at the cubed root of 16. So of these numbers, which one can divide in evenly? 8. So the third root of 16 is the same thing as 8 times 2. So the third root of 8 is 2. So the third root of 16, simplified, is 2 times the third root of 2. All right, number 7, this one's a fifth root. So I included the perfect 4s on here because there are some with the fourth root on there, so that way you have an example of them. But if you ever don't know what the perfect fourths are, you just go through 1 times 1 times 1. 1 times 1 times 1 times 1. That's your perfect perfect fourth for 1. 2, you do 2 times 2 times 2 times 2. It's 16. So on and so forth. All right, so we're looking at perfect fifths. So we have 1, 32, 243, 1,024, 3,125, 7,776, 16,807. So those are just a few of the perfect fifths. So for 7, we need to take and figure out which of these numbers can go into 160. Well, obviously 243 isn't going to go in there, so 32 or 1. Well, we're trying to simplify, so 32 can go in there. If we multiply 32 by 5, we do get 160. So this is the fifth root of 32 times 5. Take the fifth root of 32, we're going to get 2. Can't take the fifth root of 5, so it's 2 times the fifth root of 5. So that's what you guys are looking at here, is finding the perfect square that goes into these and then bringing it to the outside so that it's not underneath anymore. So we want to get what's underneath the root to be as simplified as possible. So not having any perfect squares or cubes or fourths or fifths within it. Now you have to make sure that is based on whichever root you're doing. So if it's a square, if it's a fifth root and the number you have left over is a perfect square, well, that doesn't matter. It's the fifth root. It has to be a perfect fifth in order to come outside of the root. So these are radicals. Radical is your key word for this lesson, radical. All right, the next thing we're going to look at is finding the arithmetic means for the following. So we've done problems like these before. So we're going to look at 11. For an arithmetic mean, we take the last number minus the first number. So negative 10 minus 18 over 5 minus 1. Now, this may look pretty familiar to you. It should. This is slope formula. So you're finding the slope because that's your common difference or your arithmetic mean to go between these. So negative 10 minus 18 is going to give you a negative 28 over, you're going to take 5 minus 1, and then you're going to take and end up with 4. And negative 28 divided by 4 is negative 7. So 18 minus 7 is going to give us 11. 11 minus 7 is going to give us 4. 4 minus 7 is going to give us a negative 3. And negative 3 minus 7 is going to give us negative 10. So how you do each of these is you take the last term minus the first term and divide it by the last term number minus the first term number. So it's your slope formula. y2 minus y1 over x2 minus x1. So y2 minus y1, x2 minus x1, for those of you who need to see that. So you're doing slope for arithmetic means, okay? All right, the next section, 13 through 15, is the geometric mean. So these are a little different. So we're doing 14 together. So we take and start with our last number, so 875, and we divide it by our first number. So we're going to divide it by 7. So 875 divided by 7 is going to give us 125. So we have 125. Now we look, we have 4 and 1. So 4 minus 1 is going to give us 3. So that means we're taking the third root of 125. So for geometric, we're taking a root. For arithmetic, we're dividing by that difference. So the third root of 125, well, if we look back up here, perfect cubes, we see 125. It's the 1, 2, 3, 4, fifth one over. So the third root of 125 is 5. So 7 times 5 is 35. 35 times 5 is 175. And 175 times 875, or 175 times 5 is 875. So there's our geometric mean. So it's about taking the root. So you're going to take the root of the number to find out what your geometric mean is, or your ratio is, okay? All right. The next thing we're looking at, let me shrink this back down. So fill in the tables of values and find the factor used to move between whole number values f of w as well as the factor f of c used to move between each column of the table. So we are going to look at number 18 together. Yes, all the way down there. So we're looking at 18 together, and I do have this drawn out on my board. So we have x with 0, a half, 1, 3 halves, and 2. And then our y value for 0 is 5. For 1, it's 15. And for 2, we don't know it. But what's the relationship? How did we get from 5 to 15? We multiplied by 3. So we should do that again. So 15 times 3 is 45. So our f of w value is 3. Now, for the in-between, so this is like what we did before. We know this is 3. There's 2 places. That means we're going to take the square root. So this will be 5 root 3, and this will be 15 root 3, because that's root 3 each time. So our f of c is root 3. So remember, it's whatever we are using to get between the whole numbers. We take either the square root, the cubed root, the fourth root, depending on how many places there are in between. So being as this is split in halves, it's the square root. All right. The last section that we're looking at is find the desired values for each function below. So we are going to look at 19 together. So we have f of x equals 2x minus 7, and we want to find f of negative 3. We want to find f of x equals negative 21, and we want to find f of 1/2. So when we have the f of a number, so when it looks like this one and this one, that just means we're plugging in the value inside for x. So we have 2 times negative 3 minus 7. 2 times negative 3 is negative 6. And negative 6 minus 7 is negative 13. So f of negative 3 is negative 13. Now, when we have f of x equals 21, that means this whole expression here equals 21, and we need to solve for x. So 21 equals 2x minus 7. We'll add the 7. So 21 plus 7 is going to be 28 equals 2x. So then we divide by 2. So x equals 14. So for the f of x equals something, those ones you're going to solve to find what x is. So you're going to set your expression equal to that value and then solve for x. All right. And then f of 1/2, same thing as we did with the f of 3. We're going to do 2 times 1/2 minus 7. So 2 times 1/2 is just 1. And so we have 1 minus 7, which will give us negative 6. So there's our answer. All right. We're going to look at number 20 now. So here we have a geometric or exponential function. So same idea. Still, whatever the value is in the parentheses, that's going to go in for our variable. So for this first one, we're going to have 3 to the power of negative 4 times 2. Yeah, that's a negative, right? Yeah. Okay, so 3 to the power of 4 is 81, but we're looking at negative, so it's going to be 1 over 81 times 2. So our answer is 2 81sts. Oops, sorry. So whenever we have a negative exponent, it's just going to be the same as taking the value to that exponent and then moving it to the denominator. So it's going to be 1 over that value. All right, for g of x equals 162, we do 162 equals 3 to the x times 2. Start by dividing out the 2. So we're going to take the 162 and divide it by 2, and we end up with 81. And that equals 3 to the x. So then we need to figure out, okay, 3 to what power gives us 81? Well, we know that from up here, 3 to the 4th power gives us 81. So that means x equals 4. And the last one, same as before, we're doing the 1/2. So we're going to have 3 to the 1/2 times 2. Now, this one's a little weird. When we take a value to a fractional root, it's going to be the same as taking the square root or the cubed root or the fourth root. In this case, the square root, because the denominator represents the root number. So this is going to be the square root of 3, and we're going to put the 2 out front because we never want to put any multiplication after the square root because this 2 is being multiplied to the square root of 3. Okay? All right, and our last one, 22. So same thing, we're going to plug in negative 5 in for x. So we have negative 5 squared plus negative 5 minus 6.